Good afternoon, friends. I am glad to welcome you to the webinar, How to Understand Metallurgical Processes Without a Formal Education. So, my name is Andrei Karablin, and I am an entrepreneur who has been working in technically complex sales in metallurgy for almost 20 years. Our company, SmartScrap, has three areas of deep expertise: processing of metallurgical slags, selling metallurgical byproducts worldwide, improving energy efficiency at a metallurgical plant through fine-tuning of energy technological modes. And now we are developing an educational direction. Our goal is to package the knowledge we use daily to grow your business or your career. Knowledge that can be used by you as a participants in metallurgical market to improve the efficiency. To date, we worked in 35 countries and continue to work in many of them. The current market position of the company is directly connected to the use of metallurgical knowledge. Just so you understand, I don't have a metallurgical degree. Moreover, I had problems with chemistry in school. Math was fine, but chemistry, molecules, reactions, that was not my thing. But when I started selling metallurgical products, I faced reality. Without understanding the processes, you can't sell. You can't argue your point. You can't distinguish what matters from what doesn't. You can't negotiate with engineers if you don't speak their language. I faced objections, resistance, misunderstanding, and realized I needed to go after the knowledge. I was lucky. I met specialists and metallurgists along the way who explained complex things in simple language. I asked direct questions and got direct answers. I had a chance to visit the heart of steel mills with my mentors. I didn't read textbooks because they are written for metallurgists. There is no metallurgy for dummies section in them. But I had real experience and I applied that knowledge in practice. Step by step, I began to understand metallurgical processes, and then I began to teach my employees. Almost none of them have a metallurgical education yet. They work in technically complex sales and solve tasks at the intersection of technology and business. Because I passed on that knowledge, simplified but accurate. Today I speak at international conferences. My articles are published in industrial magazines, and I host a podcast with leaders of global steel industry. And I also created the online course Fundamentals of Metallurgy, specifically for people like I was 15 years ago. For those who are not engineers but need to understand metallurgy to be strong professionals. My approach is simple. Each of us has our own unique talent. I can explain complex things in a simple way. For example, I run a Telegram channel where I explain to my followers what's written in the Bible. And I want my talent for simplifying complex things to serve you today. I believe every person can understand the essence of metallurgy. Not everyone will become a metallurgist, but anyone can figure out what reduction, oxidation, slag, furnaces, and alloys are. This will give you a competitive advantage, confidence, and strength both in negotiations and in decision making. Why it is important to understand metallurgical processes? Let me give you a few examples from my own experience working with metallurgical enterprises. A large metallurgical holding, registered in Switzerland, has its own steel plant and other production facilities. We are negotiating slag processing at one of their plants. The marketing director is involved. During the conversation, I realized he doesn't know that after the electric arc furnace, their plant also uses a ladle furnace. And therefore, there are two types of slag produced at a steel mill with an electric arc furnace, one after the main furnace and one after the ladle furnace. These slags have different properties and accordingly different pricing. Is it important for marketing director to know this? In the context of bid negotiation, the marketing director was responsible for pricing. I realized Slack was a new topic for him, and in this case, he simply was not prepared for the task set before him. Second case, I visited a steel mill in Africa, blast furnace converter process. We were inspecting a slag dump. We wanted to process it. The conversation was cold. At a certain point in the negotiation, I got the idea to show the advantage the plant would get from the processing of slag. I draw on a piece of paper the material fractions that would be produced during slag processing 0 to 10, 10 to 70, and 70 to 300 millimeters, etc. Then I show that magnetic fraction from 0 to 10 millimeter can be used as an iron ore substitute. I was not talking about any kind of know-how, but everyone in the room felt something important happened in that moment and the conversation warmed up. Because my skill in metallurgy helped me to find benefit for clients. Today, sales are becoming more complex, and in heavy industry, which includes metallurgy, solution providers are valued more than just raw material or equipment suppliers. To be one, you need to understand how your potential customer produces their product and makes money. This way, your negotiation options are not limited just to price and payment terms. So, next let's go to the practical things. I want today's webinar to be useful. Let me share with you part of the material from my course and highlight the most essential fundamentals of metallurgy, which revolve around oxidation and reduction processes. Iron often exists in compounds with various chemical elements. One of the most important aspects for us is analyzing the forms of iron in compounds with oxygen. Depending on its combination with oxygen, iron can exist in either an oxide form or metallic form. Let me explain what that means. The primary form of iron found in the Earth's crust is in oxide form. Essentially, iron ore in the ground exists as iron oxides. However, there are different types of oxides: FeO, Fe2O3, and Fe3O4. FeO and Fe3O4, these oxides have magnetic properties. This form is called magnetite, but Fe2O3 is not. It is hematite. The concept that iron ore is found in an oxide form is crucial for understanding the metallurgical process. There is also iron in a metallic form. All the steel and iron objects we encounter in everyday life are, for most part, in metallic form. The molecules of iron are not bounded to oxygen there, while other chemical elements may be present in this form, such as nickel and chromium in stainless steel cutlery to provide corrosion resistance. In this picture, you see ferroscrap as a raw materials for steel production and rebar as a final product. Both materials consist of iron in metallic form. But how iron oxides look like? Iron ore, as you might agree, is not something most of us see daily. Perhaps only a few people have visited a mining and beneficiation plant as a part of a tour or similar activity. However, oxides are present in our everyday life as well. As I mentioned earlier, iron ore is one example, but there are others. Rust is a form of oxide of iron oxide. When the surface of metal isn't protected by a stainless or galvanized coating, oxygen interacts with the surface over time, forming a rust film. This film contains iron in oxide forms. Next, just a moment, sorry. On a deeper level, for metallurgists or those more familiar with the field, there is mill scale. This forms on the surface of a hot steel billet as it exists as a continuous casting machine. As the billets cool, a flaky film develops on the surface known as mill scale, which also iron oxide. Allow me to share a mistake my friend made. He decided to sell 500 tons of turnings from South America to Pakistan. However, he was just a scrap trader and did not know much about metallurgical waste. Instead of turnings, he ended up selling mill scale. That was how our story went. So this example shows how important it is to know the fundamentals of metallurgy. Next, metallurgical slag. Those also contain iron, which can exist both in metallic form, such as iron nuggets, and in oxide forms. Let's go further. The first question: can iron oxide be turned into metallic form? The answer is yes. Many of you may have already guessed this. This process is called reduction. It takes place with the help of certain chemical elements. There is two different ways for reduction. Specifically, in the first case, carbon interacts with the oxygen molecule, and the oxygen, when reacting with carbon, is released, thereby freeing the iron molecule. As a result, iron is formed along the carbon dioxide, and iron transitions from an oxide form to a metallic form. This is a reduction process. It forms in the blast furnace. When we add coke, add carbon-containing coke as a carbon-containing material, and iron ore, its iron in oxide form, into the blast furnace, a chemical reaction occurs due to the heat. Oxygen interacts with carbon, and as a result, oxygen separates from iron molecule, producing pig iron, or liquid iron with a high carbon content from 3 to 5% and carbon dioxide. A newer method of reduction, which is becoming more popular in decarbonization trends, is direct reduction. It uses pure hydrogen or hydrogen-containing materials as a methane. And after the process, we have pure iron. It calls direct reduction iron or hot briquette iron, and water in form of steam. So we spoke about reduction, and now let's talk about the oxidation process. In the oxidation process, metallic form of iron interacts with oxygen molecules, forming iron oxides. As we discussed earlier, the oxidation of iron occurs in everyday life when the surface of the metal isn't protected from corrosion. It also occurs in certain type of metallurgical furnaces like electric arc furnaces or basic oxygen furnace. In electric arc furnace, oxygen is blown into the furnace as an additional energy source to increase melting speed. While electricity provides the primary heat through electrodes, additional heating is provided by oxygen burners to optimize furnace operation. As oxygen is supplied, some of the iron in electric arc furnace oxidizes, which is why electric arc furnace slag often has a high content of iron oxides. Oxidation also occurs in the basic oxygen furnace. The heating is carried out by injecting oxygen under high pressure, and oxygen interacting with iron oxidizes it, converting part of the iron in the form of oxides into slag. So all these processes we will discuss deeper during the course. As a summary, let's see the definition of the metallurgical process. It is a combination of physical and chemical processes aimed at obtaining a specific metal from metal-containing raw materials. Sorry. So now let's take a look at the steel production flow chart and briefly go through each process. We see here coke and coal and iron ore as raw material, and we see here different route: blast furnace and converter route, and electric arc furnace route for steel production. For blast furnace as a raw material, we see that we need coke. So coke and coal is used to produce coke in coke oven plant, and we have coke as a carbon-containing material, and iron ore. Iron ore has low Fe content, iron content, and it goes to beneficiation plant to increase iron content in iron ore concentrate. Then this material goes to sinter plant for the production of agglomerates, and this raw material as agglomerate and coke goes to blast furnace. After blast furnace, we have liquid iron, and liquid iron goes to the converter, or in a different name, basic oxygen furnace, and it is mixed here with scrap in proportion 70% of liquid iron and 30% of scrap. And it is a secondary metallurgy. Let me come back a little bit later. So another route is electric arc furnace. For electric arc furnace, we have as a raw material scrap, pig iron, and DRI. DRI is produced from iron ore. We see here again, iron ore goes to beneficiation plant. After beneficiation plant, we have iron ore concentrate. Then iron ore concentrate goes to pellet plant. We have pellets, and pellets goes to DRI kiln to produce direct reduced iron. And all this material as a DRI, scrap, and pig iron can be used in electric arc furnace. After converter and electric arc furnace, liquid steel goes to ladle furnace. Ladle furnace, the purpose of ladle furnace is to adjust steel in a correct chemical composition. So in ladle furnace, we reduce harmful elements like sulfur, copper, and phosphorus, and increase useful elements like nickel, chromium, molybdenum, or others. Then liquid steel goes to continuous casting machine, and we have billets. The billets goes to rolling mill, and in rolling mill, steel mill produces a long product like sheet, rebars, different profiles, bars, wire rods, etc. So this is what we are going to speak in the course. And so let me speak about the course fundamental of metallurgy. What included in the course? We created a course that helps you understand metallurgy from scratch. If you are not metallurgist by education but work in the steel industry and need to understand how everything works. The course includes 12 video modules, short, concise, and clearly explained. Visual diagrams and slides for each particular processes. Practical examples and explanations of how this knowledge applies at work. Review questions at the end of each module. Access from anywhere in the world anytime. Who this course is for? Let me start with who doesn't need it. You don't need this course if you already have a basic education in metallurgy, but you can recommend it to your colleagues so they better understand steel production specifics and you can speak to them the same language. Who needs the course? Anyone working in or around the metallurgical industry, regardless of position. Chiefs of departments, financial managers, marketing directors, logistic managers. I don't overload with technical terms. I explain things in a very simple language. I don't give fluff, only what is truly useful. From the differences between electric arc furnace and basic oxygen furnace to the purpose of oxidation and reduction processes in iron. And most importantly, everything is explained through practice. So let me tell you one of many cases from our work where knowledge of metallurgy helps us. We shipped scrap to Japan. It is not traditional scrap. It is alternative scrap, extracted from slag. It calls skulls. And Japanese customs was not familiar with such kind of the material. The customs authorities asked what the material was and requested a description of the production process. We reached out to the producer. The response was that this scrap was metal that had been loaded into the furnace but had not yet melted. But that's not actually the case. Liquid metal from the electric arc furnace flows into the ladle furnace. Unmelted scrap cannot reach the ladle furnace. In the ladle furnace, slag is formed using lime to conduct specific processes. During slag tapping, some metal also flows out and solidifies on the slag dump. It is then recovered during slag processing. And we had to write the process description ourselves and successfully resolved the custom clearance issues. Today, the topic of our webinar is how to understand metallurgical processes without a formal education. And I will outline several approaches. So, first of all, you can study material on your own. Today, you have free access to almost any information. You can study everything independently. YouTube, ChatGPT, all of these will help you understand the subject. I want to give some tips of advice. The first one is to read the book called Learning to Learn. I remember a very important point from it. Sometimes when you study something, you start dozing off, zoning out, your thoughts drift away. This is a sign that your brain has stumbled upon an unfamiliar word. You need to go back in the text and find the word whose meaning is unclear to you. These may be unfamiliar words or common words that have multiple meanings. Then you need to look up the meaning using dictionaries. You can ask ChatGPT and clarify the unknown term. Using this technique, your study process may take a bit longer, but you will gain deeper knowledge. You will feel the material, and it will be harder to forget it. Another important tip: if you work at a metallurgical plant, go to the production site more often. After university, I worked for 4 years at a steel mill in the purchasing department. I often visited the steelmaking shops, rolling mills, spoke with technologists and metallurgists. These visits not only helped me understand metallurgical processes better, but also strengthened my relationship with technologists and metallurgists, and it helped me to fulfill my responsibilities easier. If you don't work at a metallurgical plant, but visit one during business trips, ask to be shown the production facilities. In my experience, visiting the production site strengthens relationships. The temperature of the relationships rises when you step out of the meeting room and visit a production site. And the second way of learning to find a mentor in metallurgy. A mentor will allow you to learn much faster. In fact, you are paying for saving time. A mentor will give you answers to your question much quicker. It's important to find the right mentor. I was lucky. I found my teacher. I called him the world champion in metallurgy. When it comes to the furnace optimization, he and his team performs miracles, reducing electricity consumption by 10 to 15% in just a few days, saving our client millions of euros. And all the time, when I asked him technical questions, he answered in a very simple way. So I understood the metallurgical process. So today, you can use me as your teacher in the field of metallurgy. And before we move on to the question and answer section, let me tell you about the two course packages available to you. First package, standard. It includes 12 short videos, presentation, handouts for the course, and at the end of the course there are exam questions. You are not required to answer them, but if you do and send them to us, I will provide you feedback and may adjust your answers. This package also includes one call with me to consolidate the material, and you have a chance to ask me specific questions regarding your working responsibilities, so we can make a program exactly for you. The price of this package is 250 euros. Second package, VIP, includes the same videos and exam questions, but support in my involvement in up to 5 meetings of the course of 3 months. So we can work with you much deeper, exactly with your job requirements, and I am sure it will help you to increase value in your current position. The price of this package is 500 euros. And today we have gift for you. You get 25% off if you pay within 48 hours by 6 p.m. Central European Time on August 14th. So please use this chance to improve your skills and earn more. So here you see the QR code for the registration. Also, my colleagues will share the link for the registration in the chat. Can you check if the link works? So you can check it, and now we can go there to go to session of questions and answers. Let me chat. My colleagues, can you send me questions? Is there any questions? So there are no questions. You ask to send the presentation. So this presentation includes to the course. I would be happy to invite you to other online events, and I can share some more information specifically for you. But let me think about the presentation, what we use today, okay? And also, if you please find us on LinkedIn, and I hope that we already connected because we shared a lot of technical information in our posts. So we post almost every day and we share technical, complex information. So, and also we are very, very active in online events like today. So I see question. I wanted to ask that we are facing comparatively high energy consumption in our electrical furnace from last few days. Can you give us few tips to save some? We make stainless steel via scrap melting route. So yeah, it's a good question. First of all, as I told you before, I am not the metallurgist, so I explain to non-metallurgists fundamentals of metallurgy in a very simple way. But we can discuss this question exactly with our team. For example, today, two people from our team working in Middle East in steel mill in our client. It's also the target of this service is to reduce electricity consumption. So we can discuss later about your current numbers, and we would like to see your information like melting reports, etc., 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 and then to advise something. Okay. Any question? And in general, if everything was clear, like regarding the reduction and oxidation process, can you tell something? Maybe it was not clear, and I can repeat it again because I want you to give value today. Let me come back. This reduction and oxidation process was clear or not? So can you please repeat? So there is it about high energy consumption, right? Question. So yes, Mr. O. Mishra, as I tell you that my technical team can assist you, but I have to understand your situation. We will need your information, like what is the electric consumption right now, what is your production, what kind of raw material do you use, and we want to know uh, information about your electric arc furnace, melting reports. And if you provide this information to us, I'm sure that we can help you because we can do it. We did it in many projects to reduce electricity consumption, to reduce melting time, etc., etc. Tandish. Need training session on Tandish methodology and caster. Okay, so let me work on it. Mhm. Mhm. So as I understand today, we have not only non-metallurgists in our audience. Yes, we have some already metallurgists and they know the fundamentals, and you need some more technical information, some specific information regarding some meltings and other stuff, like production of steel. Yes, you can send us question what you exactly need, and if it is related to our expertise, for sure we can make something. Mhm. Can you share this presentation? Mm, I think yes. Let us give this way. So, if you need the presentation from this webinar, from this online event, you can send just comment, present, please presentation, and just presentation, and my colleagues will send it to you. Okay, we will share it. No problem. Just write it down that presentation uh, in the comments. And also, you can look at the this event in the recording, and we will provide you also the link to our YouTube channel, and it will be recorded there because maybe you can lost it on LinkedIn. So we will provide the link to this video on YouTube, and we will give you the presentation from this online event. Mhm. Similar happens on zinc production. In this case, is converting zinc O into zinc, but also works the other way around, converting zinc into zinc O. Yes, exactly. It's also in ferrous and in non-ferrous material. So the metals, different kind of metals, not only iron, also non-ferrous. It's in compounds of oxygen, and then if you need this metal in metallic form, so you have to separate molecule of iron and molecule of metal and molecule of oxygen, and it can be in a different way. Sometimes it's hydrometallurgy, pyrometallurgy. Sometimes you have to melt it. Sometimes you use some chemical elements, etc. Mhm. Okay. So, friends, if you need the presentation, if you need the link to watch again the video, please write in the comments presentations, and we will send you the link to our YouTube channel, and we will send you this presentation from this online course. And again, if you need technical information, and if you want to speak about uh, the course, please contact us and we will discuss. Maybe you have some questions, you have some doubts. We can discuss about the course. I can explain you what you are going to have if you buy it. Thank you very much for your attention, and I hope to see you somewhere at our webinars and our online events, some interviews. So let's stay in touch. Bye bye.